Alright, now we are in chapter 8.2 and we're going to be solving equations using the addition property. An equation is of the form where we have an expression on the left side equaling an expression on the right side. They give us the example x plus 7 equals 10. The expression on the left is the x plus 7 and the expression on the right is 10. This is an equation because of the equal sign. Expressions do not have equations. And they give us a few examples below. So we have an equation as 7x equals 6x plus 4. And then the expression could just be 7x minus 6x minus 4. Notice in your equation you have an equal sign, and in your expression there isn't an equal sign. So now let's see how we're going to determine whether a number is a solution to an equation. So finding the values of variables that make an equation a true statement is called solving an equation for the variable. So again, when it says solve, that's when you're looking for the values of the variable that make your equation true. A solution of an equation is a value for the variable that makes the equation a true statement. So what does it mean by the true statement? That is where the left side of my equation, so let me write it left side, comes out and equals my right side of my equation. The steps for determining whether a number is a solution. Step 1. Replace the variable with the given value. So they're going to tell you x equals 5 or x equals 2. Whatever that number is they give you, you're going to plug it in for the variable. And then step 2 is a question. Does the left side equal the right side? So does the left side of your equation equal the right side of your equation? If it's yes, then the value is a solution. If it's no, the value is not a solution. Alright, let's go on our books to page 574 and we're going to look at the following problems starting with number 1. It says decide whether the given number is a solution of the given equation. And it says is 10 a solution of x minus 8 equals 2? So I need to determine whether 10 is a solution. So I'm going to take the 10 and I'm going to replace it with the x. So everywhere I see an x, I'm going to put in 10. So now it's going to say 10 minus 8. And I still have the equals and I still have the 2. Well, 10 minus 8 is 2. And 2 does equal 2. Therefore, 10 is a solution. So again, take the value, replace the variable, work it out, and see if the left side equals the right side. Alright, and then number 3. So now it says, is negative 5 a solution of x plus 12 equals 17? So just like before, we're going to take the value they gave us, which was the negative 5, and we're going to replace the x. So now it's going to say negative 5 plus 12. And remember, keep everything else the same. And now we're going to work it out. Negative 5 plus 12, well, that is 7. Does 7 equal 17? The answer should be no. Therefore, no, negative 5 is not a solution. Alright, so now we can talk about how do we solve equations. The first property will be the addition property. The addition property says the following. The same number may be added or subtracted on both sides of the equation without changing the solution of the equation. In another sense, when I'm solving an equation, I want to move all numbers away from my variable. In order to move a number away from your variable, you want to do the opposite. So let's say I had a number that was adding. In order to move something that is adding, I would subtract. Or let's say I had a number that was subtracting. The only way to move something that's subtracting is to add it. So again, to move numbers away from your variable, do the opposite. The opposite of adding is subtracting. The opposite of subtracting, well, it's adding. All right, let's look at the following problems in our book on page 574. We're going to start with number 9. And it says solve, and then of course it says check each solution. And for number 9, we have a plus 5 equals 23. All right, so we're going to solve this. To start us off, I'm going to draw a line down my equal sign. This is going to represent my gate. This is the left side of my equation, and this is the right side of my equation. My goal is to get all the values away from my variable. My variable is a, and who's on his side with him? The plus 5. Because it's adding, I'm going to do the opposite, which means I'm going to subtract 5. And subtract 5. On the left side, I'm left with a, because the 5 minus 5, that cancels out. So I have a equals, and then do 23 minus 5, and we get 18. I know I'm finished when I see a by itself on the left side of the equation. So the answer is a equals 18. Now I can check the answer by taking the 18 and plugging it back in for a. So everywhere I see an a, I'm going to put the 18. So this is check. So I have 18 plus 5, and I have that 20 equals 23. And let's work it out. 18 plus 5, well, that's 23. 23 does equal 23, so this is my correct answer. All right, let's look at number 11. Now we have d minus 9 equals negative 17. So d minus 9 equals negative 17. We're going to do the same thing again. Draw the line down the equal sign. This represents my gate. This is the left side of my equation. This is the right side of my equation. My variable is d, that's my letter, and I want to move the minus 9 away. It's subtracting, therefore I'm going to add 9 on both sides. On the left side, I'll be left with only d, and it'll equal, well, the negative 17 plus 9, that's negative 8. And again, you can check it by taking it and plugging it back in. All right, number 17. We have x plus a half equals 7 halves. And again, our goal is to solve for the variable. So I'm going to draw the line down my equal sign. I'm solving for x, that's my variable. I want to move the half, it's adding, so I'm going to subtract. So I'm going to subtract the half and subtract the half. And I have x equals 6 over 2, which is the same as saying 3. And that's your final answer. So remember, when it says solve, your goal is to get the variable by itself. And it's going to equal an answer or a value. Number 21. We have x minus 3 equals negative 1 plus 4. This time, I'm still going to draw the line down my equal sign to start with. That's my gate. However, on the right side, instead of just having a single value, I have like terms. So I'm going to go ahead and start by combining my like terms. Negative 1 plus 4, well, that gives me positive 3. And then I still have the x minus 3. Now I can actually solve for my variable, and I need to move the minus 3, so I'm going to do it by adding 3. I'll have x equals 6. And there's your final answer. All right, let's keep going. Number 31. It says negative 8x plus 4 plus 9x equals negative 1 plus 7. So again, let's start by drawing the line down the equal sign. When I look on the left side, I have like terms again. The negative 8x plus 9x. Remember, if we cover up the 4, we literally see negative 8x plus 9x. If I combine them, that just gives me x, or 1x. Don't forget the plus 4 was still there. You still have your equal sign. And then on the right side, again, I have like terms, so let me combine them. Negative 1 plus 7, well, that is 6. So I have x plus 4 equals 6. Solving for x, which means I need to move the plus 4, so I'm going to subtract 4 on both sides. And we get x equals positive 2. And remember, you can check them by plugging back in for x, and you want to see if the left side equals the right side. And then 37, it says solve, but then it says first multiply to remove the parentheses. And we have 2 times 5x minus 3 equals 11x. So the first thing I want to do, if I ever see parentheses, I need to get rid of the parentheses, so I'm going to use the distributive property. Remember, that means that the number on the outside is going to be multiplied by every number or every term on the inside. So 2 times 5x, well, that is 10x. And then 2 times negative 3 is negative 6. So I have 10x minus 6 equals 11x. Now let me draw the line down my equal sign once again. This time I have x's or variables on both sides of my equation. Before I can solve for the x, I need to get the x's together. So always move the smaller x. I have 10x and I have 11x. Who's smaller between the two? It will be the 10x. Now realize this is a positive 10. So in order to move a positive 10, you're going to subtract 10x. Subtract 10x. You're taking the whole thing. So I'm going to subtract it. It cancels out. I'm left with negative 6 equals, and then 11x minus 10x, well, that is just 1x, or you can say x. So x equals negative 6. Notice how I can rearrange how I write it. The x was on the right side, but if I want, I can put it on the left side, and I can move the 6, as long as I keep the sign the same. It's negative 6. And then last one, number 43. It has negative 3, parentheses, negative 4, minus 2z equals 7z. So again, I see parentheses, so I'm going to start there. I'm going to start by distributing the negative 3 on the inside. Realize it's a negative 3, so be careful with your signs. And remember, distribute means multiply. So negative 3 times negative 4 is positive 12. And then negative 3 times negative 2z, well, that's positive 6z equals 7z. Now let's draw the gate down the equal sign. I have variables on both sides of my gate. I need to get them together. So I'm going to move the smaller, and the smaller between the 6 and the 7 would be the 6. So we're going to move it by subtracting 6z on both sides. Don't forget the z is a part of it. So minus 6z. On the left side, I still have 12 equals, well, 7 minus 6, well, that's just 1z, or we'll say z. So z equals 12. Okay, so this will conclude our video for chapter 8.2. Please email me if you have any questions.